Hello and welcome to my first commented video here on this channel. In this video I want to show you my little procedural terrain generation tool that I have been working on for the last few months. It was the first time for me to experiment with procedural generation, so it was quite an adventurous journey for me. Right now you can see some examples of what my tool can do. In the following I will explain how I got there and what challenges I was confronted with. Let's start with this simple generated mesh so I can show you the effect of the main parameters that affect all areas of the mesh. It's possible to change the size of the mesh, while the resolution changes the number of polygons. To make the terrain appear more organic, it's important that there are height differences. The tool has various parameters to control the height distribution on the mesh. Inspired by various tutorials here on YouTube, I programmed the tool to add purling noise with different granularities. The number of octaves determines how many times a summand is added to the result. With each octave, the noise granularity gets finer, while the amplitude of the added noise gets smaller. In the current state, the terrain still looks pretty boring. As you could see at the beginning, the tool supports multiple terrain types, not just one like on the mesh you can see right now. In some games that use procedural terrain generation, these are also called biomes. However, the term biome describes an area that is defined not only by the material and structure of the ground, but also by its flora and fauna, which is not yet implemented in my tool. That's why I'll stick to the term terrain type here. When I create a new terrain type, I first need to assign a name, material and color. I'll come back to the purpose of the color later. Besides this, I have basically the same control parameters for height distribution I described before. What's different is that they only influence the height structure of the current terrain type, which is added to the height structure of the whole mesh. Finally, I can also give each terrain type a height offset to make it stand out from its surroundings. You can see that the different terrain types are randomly distributed across the mesh. Making it look as natural as it does now was one of the biggest challenges of the project. My first approach was to use Voronoi noise. Voronoi noise can create cellular patterns such as those often found on animals and plants. I created a data structure which I call the terrain map, which stores the relevant data of the terrain. I then implemented a Voronoi-based algorithm that randomly assigns each cell to one of the existing terrain types. I have created a visual representation that allows better understanding of the terrain map, which also explains what the colors are needed for. The Voronoi algorithm already resulted in something that was pretty much what I had in mind. I just wasn't happy with two main aspects. First, the borders were straight. I solved this by simply adding some purling noise when calculating the Voronoi cells. Another issue becomes apparent when we examine the mesh itself. There is no smooth transition between the terrains. This meant I had to create an interpolation algorithm somehow. There are already versions of the Voronoi algorithm with smooth borders. What's different in my case is that I don't just create a bitmap where I mix colors together. What you see here is only the visual representation of the terrain map. In fact, the algorithm creates a two-dimensional array where every entry contains the proportions of the surrounding terrain types for a particular point. From these proportions we calculate the height map, which then results in the final mesh. With these two parameters, which I call border granularity and border smoothness, I have lots of possibilities to adapt the look of the borders to my wishes. If you take a closer look, you'll see that the transition between the different height profiles is smooth, but the actual material isn't. You can see that each triangle of the mesh is covered by one single material, making the triangles clearly visible. That's because I'm still using the standard lit shader in Unity. With this, creating a mesh with multiple materials is only possible by using submeshes. That's why the next big step from a project would be to write a custom shader, which would bring a lot of other advantages too. I hope to be back with another video soon to show you my progress, so don't forget to like and subscribe. Thanks for watching, goodbye.